My name is Ashu and I am here to present my presentation on the topic oscillator. Introduction to oscillator. Oscillator is an electronic circuit that generates a periodic waveform on its output. Without an external signal source, it is used to convert DC to AC. Oscillators are circuits that produce a continuous signal of some type without the need of an input. These signals serves a variety of purposes. Communication system, digital system including computer and test equipments make use of oscillator. Objectives. Describe the basic concept of oscillator. Discuss the basic principle of operation of an oscillator. Analyze the operation of RC and LC oscillator. Describe the operation of the basic relaxation oscillator circuit. Some important terms: oscillation, an effect that repeatedly and regularly fluctuate about the mean value. Oscillator, circuit that produce oscillation. Characteristics: wave shape, frequency, amplitude, distortion, stability. Application of oscillator. Oscillator are used to generate signals. Used as local oscillator to transform the RF signal to IF signal in receiver. Used to generate RF carrier in transmitter. Used to generate clock in digital system. Used as sweep circuit in TV sets in CRO. Oscillator are circuits that generates periodic signals. An oscillator converts DC power from the power supply into AC signal power spontaneously without the need of an AC input source. An oscillator is a circuit that produces a repeated signal from DC voltage. The feedback oscillator relies on a positive feedback of the output to maintain the oscillation. The relaxation oscillator make use of an RC timing circuit to generate a non-sinusoidal signal such as sine wave, square wave, saw-tooth wave. Type of oscillator. There are three types of oscillator: RC oscillator, LC oscillator, and unijunction relaxation oscillator. RC oscillators are two types: Wien bridge oscillator, phase shift oscillator. LC oscillator are four types: Hartley oscillator, Colpitt's oscillator, crystal oscillator, clap oscillator. How do the oscillation get started? Noise signals and the transients associated with the circuit turning on provide the initial source signal that initiate the oscillation. Practical design consideration. Usually oscillators are designed so the loop gain magnitude is slightly higher than the unity at the desired frequency of oscillation. This is done because if we design for unity loop gain magnitude as a slight reduction in gain would result in oscillator that dies to zero. The drawback is that oscillation will be slightly distorted. Basic principle for oscillation. The feedback oscillator is widely used for generation of sine wave signal. The positive feedback arrangement maintains the oscillation. The feedback gain must be kept to unity to keep the output from distorting. RC oscillator. RC feedback oscillator are generally limited to frequency of 1 MHz or less. The type of RC oscillator that we will discuss are the Wien bridge and the phase shift. LC oscillator use transistor and LC tuned circuit or crystal in their feedback network. For 100 of kHz to 100 of mHz frequency range, examine Colpitt's, Hartley and crystal oscillator. Thank you and very much.